Hi, our lesson today is about the gas laws. We will study together four laws or three main laws, which are Boyle's law, Charles' law, Gay-Lussac law, and finally the combination of three laws, which is called the combined laws. First of all, let's start with the factors that affect the gases. Number one, temperature that can be in Kelvin or Celsius. Number two, pressure that can be in atmosphere, kilopascal. Number three, the volume, which can be in liter, and volume, which is and the number of moles, okay, that represents the amount of gases. Boyle's law studies the relation between the volume and pressure. And if you notice the graph, you can see that there is an inversely proportional relationship between pressure and volume, because as you notice, as the pressure increases, what happens to the volume? It decreases. When volume decreases, the particles are crowded in small area and consequently collisions increase. Boyle's law is P1 V1 equal P2 V2, where P1 V1 represents the volume and the pressure and volume in initial condition. P2 V2 represents the pressure and volume in final conditions. Example: a balloon contains 30 liters of helium gas at 103 kilopascal. What is the volume of helium when the balloon rises to an altitude where pressure is only 25 kilopascal? 30 liters represents the V1. 103 kilopascal represents what? The P1. 25 kilopascal represents the P2. So what is the volume? So I need to find V2. According to Boyle's law, P1 V1 equal P2 V2. So by substitution, P1 is 103, V1 is 30, P2 is 25, and V2 is the X. By applying the shift solve, you can get the result, which is V2 103 times 30 over 25. So the result will be 123.6. So the result will be 123.6 6 watt liter. So this is the answer of this question. Rule number 2, Charles' law. Charles' law is the rule number 2 that studies the relation between volume and temperature. Volume and temperature. With respect to pressure, pressure is constant. If we move little back to Boyle's law, it studies, as we said, the relation between pressure and volume. What about temperature? Temperature is constant. In Charles' law, there is a proportional relationship between temperature and volume. As temperature increases, volume also increases. And the rule is V1 over T1 equal V2 over T2. This is the Charles' law. Temperature should be in Kelvin, and in order to change from Celsius 2 Kelvin, simply you add 273. Kinetic molecular theory. Before moving to Gay-Lussac law, we should know the kinetic molecular theory that states that small particles make up all matter. So all matter and every matter is made up of all particles. These particles are in constant random motion. And the particles collide with each other. With each other and with the container, inner wall of the container. And knowing that, during collision, no energy is lost. Let's solve an exercise on Charles' law. Let's solve the exercise 4, page 446. What volume will the gas in the balloon at the right? So we have a balloon, as you notice. The volume, it is volume 1, is 4.3 liter. Temperature is 350 Kelvin. So what volume will the gas in the balloon at right occupy at 250? So please open on page 446, question number 4. So I need to find V2 if T2 is equal to 250 Kelvin. So according to Charles' law, V1 over T1 equal V2 over T2. V1 is 4.3, T1 350, V2 our target, which is X, and T2 is 250. The answer after calculation will be 3.1 liter. Let's start with the third law, which is called the Gay-Lussac law. Gay-Lussac law studies the relationship between pressure and temperature, and this relation is proportional. As you see here in the graph, as the temperature increases, the pressure increases. So as the temperature increases, pressure increases. And the law is P1 over T1 equal P2 over T2. So when temperature increases, the particles move faster, and these particles make more collision on themselves and on the inner wall of the container. So if you notice before, at 150 Kelvin, the pressure was 1 atmosphere. When the temperature is doubled, the pressure also doubled. It becomes 2 atmosphere, which means that the relation is proportional. Let's solve an exercise on Gay-Lussac law. Please open on page 448, question number 8. The pressure in an automobile tire is 1.88 atmosphere. So P1 equal 1.88 atmosphere. The temperature is T1 equal 25 degrees Celsius. What will be the pressure if the temperature increases to 37 degrees Celsius? If temperature increases to 37 degrees Celsius, what will be the P2? According to Gay-Lussac law, P1 over T1 equal P2 over what? T2. So P1 is 1.88 over T1, 25. That should be converted into Kelvin. P2 is the unknown, and T2 is 37 plus 273. So by calculation, we get the P2, which is 1.96 atmosphere. Now, let's move to the combined law. Combined gas law states the relationship among pressure, temperature, and volume of fixed amount of gas. This law combines the pressure, volume, and temperature of initial and final conditions in one equation, which is P1V1 over T1 equal P2V2 over T2. This is the summary of Boyle-Charles, Gay-Lussac laws, and the combined laws. Let's solve an exercise that includes the three laws together, which I mean the combined gas law. Kindly open the book on page 450. We're gonna solve exercise 11, page 450. A sample of air in a syringe exerts a pressure of 1.02 atmosphere. So I have, let's say, P1 equal 1.02 atmosphere at 22 degrees Celsius. So temperature T1 is 22. Don't forget to convert it into Kelvin. The syringe is placed in boiling water bath at 100 degrees Celsius, which is T2. It is 100 degrees Celsius. The pressure is increased to 1.23 atmosphere, where the volume V2 equal 0.224 milliliter. The question is, what was the initial volume? Okay, so let's apply the combined law, because according to the given, pressure, temperature, and volume are found. So according to the combined law, P1V1 over T1 equal P2V2 over T2. P1 is 1.02, V1 is the unknown, T1 is 22 plus 273, P2, so this is the P2, is 1.23, V2 is also given 0.224, T2 is 100 degree, and we need to convert it. As you see, it is an easy question. Everything is given, so just apply the rule. After calculation, V1 is 0.214 milliliter, and you can convert the volume from milliliter 2 liter by dividing by 1000. Good luck.